Hi everyone. Good evening everyone. How are we doing? I'm not supposed to comment. Good evening, Anwar. How you doing? Trust you are good. Let's wait for the other tech sisters. Okay. Oh, I guess Mojo is I'm just seeing you. For me, I'm just seeing you for the first time. Good evening. Good evening. Good evening, Aguda. Good evening, Rabio. Good evening, Ayola. I'm doing great. Very, very fine. Let's wait for our reminiscences. Good evening, Cecilia. I'm good. And you? Good evening, Mohammed. Good evening, Robert. Okay. Good evening, everyone. Good evening. So let's give our other texts some minutes to jump on in. Good evening. Good evening. Good evening, Jackson. Good evening, Deborah. Good evening, Miracle. It's nice seeing you guys again. You ladies. You ladies actually you're trying, seriously. You're trying. To be able to keep up and be consistent in this journey. Trust me, you are really strong. So we'll be starting by 7:05. So let's just give others, or let's give others about 2 minutes. Let me pull up the YouTube channel. Let me see how many people we have live. So if you want to drink your tea, I know some of us may be watching maybe from our offices, so we don't want to um, get on the traffic. So maybe after this class, around that 9, those of us that work on the island and we stay in the mainland, the traffic around this time always is always very strong. So just wait sometimes till around 9 when everything has settled down. So let's just wait for others to come in. Good evening, for Insula. It's nice seeing every one of us. So if you are new here, if you are new here, can you just give me a shout out? Good evening. Good evening. Hmm. Deborah, are you new here? Yes, I know. So I know, Omojo, I know you are new here. Excuse me. So can we fly? Can we fly? Okay, then where are you too? So can we fly? Can we fly? Or we should give others some few minutes. Let's stretch. Let's stretch ourselves. So let me get. Huh. Peace. I guess peace is new. Or maybe it's my eyes. Mm, mm, we have 30 people here. Ooh. Deb is new. So when we start, I don't want anybody to be throwing me back. Oh. Nobody should throw me back. Oh. But don't worry, I'm here for you guys. Okay. So can I get a fly if you want us to start? 5 flies. Then we jump in. 5 flies. You know how we do it. Can I get 5 flies? One, two. Okay. Okay. So let's start. So still under networking, we started networking. We started with VPC. As introduction to VPC, spoke about some components of the VPC. And this time around, we're not going to be going back. So those of us that were unable to attend this on Monday's class, we can go on YouTube where we are and just quickly go through it. So today we'll just be talking about Elastic IP, NAT Gateway, and VPC peering. So can we fly? Okay, so but first, before we talk about Elastic IP, I know we talked about IP addresses in Monday's session, but I just want to give us some brief explanation, and I'm not going to go too deep into it. So um, let's just know about IP, then we can understand Elastic IP much more better. So let's first see what is an IP. We all know. Sorry. Let's see. We have two main versions of IP addresses. We have IPv4, which everyone is using. IPv6, most commonly is for IoT devices. So they are classified into public, private, static, which is elastic, and dynamic addresses. So all of them serve different purposes, but we won't be touching dynamic. So we're focusing on three of these um, IP addresses. So let's move. So we all know the definition of IP address. So an IP address in full, an IP Internet Protocol address is a unique identifier assigned to each device connected to a network that uses Internet Protocol for communication. So it serves two main function. Take note, identifying the host or network interface and providing the location of the device in the network. By now, we also know what an IP is. Every network device has an IP address. Think of IP address as your home address, so allows people to be able to find you. While I was just setting this up, the thing that always fly around my head, the the kind of analogy that always come back to my head. I just don't want to put it down. So the importance of IP address is very, very important. So think of your home address and just imagine yourself. Those of us that are in Lagos, in fact, any part of Nigeria, So just follow me. Imagine you're on your way and you just kind of meet an old woman. She gets meet an old woman and she's like, oh mommy, woman, lọ síbi kan. And you're like, ah, màmá níbo lẹ ń lọ? You say, ah, mo ò mọ̀ bẹ́ẹ̀. Wọ́n ṣáà sọ pé tí n bá ti dé báyìí, màá yà sọ́nà bíbáyìí. Màmá kí lorúkọ bẹ̀? You know, you'll be asking the woman, for those of us that don't know Yoruba, you'll be asking the woman, where is she going? You know, so I'm trying to get the address of the house. So imagine the hours you're going to spend. You know, you just feel compassion for the old woman. You can't just leave the old woman there on the road. And I understand, sorry. So I'm trying to turn it to okay, so sorry. So imagine you meet an old woman on the road, you understand, and she's trying to ask for, she's trying to get direction to a particular place, a particular house, and this old woman does not know where she's going. Many of us, you understand, we've met them on the road. So she's actually asking for direction of where she doesn't know where the address is. Many of them usually do that. So most especially because of their old age. Sometimes they tend to forget. And both of you are just standing there, and she's kind of saying, "I've been here before." I don't speak Yoruba. Say, "I've been here before," and she's trying to get the address. You know how easy and how fast it's going to be. Imagine if she has the address of the address of where she's going. Okay, so sorry about that. So imagine if she has the address of where she's going and she just gives you the paper, even though she can't reach, and say, a child wrote it down for her, blah, blah, blah. Now say, okay, mama, you are going to so and so address. If you go like this, or you still have to enter motor, you get it. So that's the importance of an address. And the same thing, you to be able to identify the host and the rest of them. So I believe that I'm so sorry for using Yoruba. Don't mind me. So I wish I can speak Igbo very well. So it's just little. So an IP address looks like this. This is the IP4 and the IPv6. So you see the IPv6 has some letters, some random figures, and trust me, is very, very long. So it's good to be able to identify between IPv4 and IPv6. So let's move. Hope you get my analogy. So let's talk about public IP now. We know what IP addresses are. So let's talk about public IP. Now it's very good for us to be able to differentiate, but it's very simple to differentiate between public IP, private IP, and what are they calling it again? Elastic IP. So you understand? So just think of public IP address, an address that is accessible over the internet. So it allows devices outside the local network to reach your device. Okay, don't let me talk about internet gateway. Don't let me talk about. But how many of us remember internet gateway that facilitated in person of Mrs. Ife she talked about yesterday. I mean, those of us that were in class, we know what an internet gateway is. How many of us remember what an internet gateway? An IGW for short. Remember? Yeah. So let's move on. Let's take look at this analogy. A public IP is like a phone number that anyone in the world can call, like anyone in the world. Yes, if someone wants to contact you, they can dial your number from anywhere because they have that number. You understand? And because the number is accessible over the network. So when you launch an instance, you assign a public IP. That instance can be accessed from anywhere on the internet. Yes, like 911. Yeah, somebody died 911. So it's 911. I don't know the number for the emergency number for Nigeria, but there's nobody that doesn't know 911. So let's move on. So if your instance has the public IP, this anyone can reach it using this IP address. Hmm? So I believe it's very simple. Let's move. So let's talk about private IP. We've known what public IP is. Now let's know what private IP. So a private IP address is used within a private network. So it can't be accessible over the internet. So it is not routable on the internet and is used for communication between devices. Take note, within the same local network, like within your VPC, for example. So a private IP is like an extension of number within a company. Employees can call each other using their extensions, you understand, without needing to go through the main line. I believe this. So let's look use an easy tool. It does not go 1112. Sadami, does it used to go? Okay, so we've seen it. That's 112. That's the emergency. 122. How many of us have even tried calling 911 for me? Let's do good. Let's focus. Let's focus. So thank you very much, Mr. Dami. So so an example, this is an easy as an example. So you might have a private address, private IP address like 10.0.0.1. So this address allows communication with other instances in the same VPC, but cannot be accessed directly over the internet. So you can this I don't know why I go and draw why did I go and draw emergency? So let's focus now. Let's focus now. I don't want to talk about it. So I believe we are, like I said, today's lesson is it's just like it's very easy, like bread and butter is not hard. So now I believe we understand private and public IPs. So let's fire through. So now we are face to face with with our main focus, that's elastic IP, elastic IP, elastic IP, elastic IP, elastic IP, elastic IP address is a static. So when we say static, something that does not move, you understand? Static, it does not move. Public IP address, take note, a public IP address is designed for dynamic cloud computing. So it allows you to associate an IP address with your AWS account and can be remapped to different instances as needed. So I wanted to quickly draw out an hands-on. You understand? I wanted us to do an hands-on for, you understand, touching IP, elastic IP address, but then I was looking at the time, but maybe, but trust me, for your level, you don't really need to know. It's at the associate level, sorry. At the associate level, that's where you need to know how to configure or how to attach an elastic IP. You just need to know what it is so you understand. But maybe I might just do an hands-on and share the video for us on how to do it. So let's take an analogy for an elastic IP. So it's like a mobile phone number that you can keep even if you change mobile providers. You can switch devices while maintaining the same number. You understand? You can switch devices while maintaining the same. It's static. You don't need to change your number just because you are changing a new phone. You understand? If you want to upgrade from, let's say, Motorola, I don't know if it still exists. Want to upgrade from Techno um, to, let's say, iPhone now. You understand? God has blessed you, and you want to use something big, that's iPhone. You understand? You can't say it's just the iPhone is two SIM, is one SIM, sorry. So, but then, which one is TSB? TSB 200. TSB. What's TSB? For Isola, what's TSB? So, you understand what I'm saying? China, yes. China iPhone. So we want original iPhone. So let's see an EC2. So if you have an elastic IP with this address, you can associate it with your EC2 instance. Yes. So if you stop that instance and start another, you can reassign the elastic IP to the new instance without changing the address. Now, the difference between these, let's say when you launch an instance now, when you launch an instance, let me quickly, because it's going to come out in your exam, I would like us to understand this. When you launch an instance, you assign a public IP address to it. You understand? Now, when you terminate that EC2 instance, the IP address is no longer available. So if you start that EC2 instance again, or you start up another EC2 instance, automatically the IP address has been changed. So you understand, if you want to make it static, you use an elastic IP address. So it's going to be static. The IP address is going to be static. So you can remove that elastic IP from that EC2 instance. Let's say you have two EC2 instance. You can move from EC2 instance A and move it to EC2 instance B. Hope you understand. So now let's just pull up the difference between the uh, three of them. So now I believe you can see my screen. And I'd like us to really understand the differences between these. You understand? So we see the future here is the public IP, the private IP, and the elastic IP. The accessibility, example use, the static, and use cases. Use case. So can we look at them one after the other? So I believe with this, you should be able to understand public IP, private IP, elastic IP. So can we move on? If you want me to fly, if you want to fly, can you tell me fly? So we can. If you like us to fly, anybody? Oh, I hope you are still here. No, not continue, sir. Yes, the word is fly. Solar, are you a newcomer? Public IP, sir. Okay. Fly, fly. Okay, so public IP, think of it that is an address that's or a phone number that can be accessible by anyone. It's public for the internet. You understand? So let's look at the accessibility one by one. So you see the public IP is accessible over the internet. Yeah, thank you. So let's look at this. Let's look at the accessibility of each of these IP addresses. So you see for the public IP address is accessible over the internet. So the private IP is accessible only within a private network. For example, within your VPC. You understand? So the elastic IP is accessible over the internet, and this one can be reassigned. So if you attach an elastic IP to an instance, even when you terminate that instance, the IP is static. Take note of that. It's static. It's static. We've not started talking about internet gateway. Yes. Okay, you get it, Abby. You get it. If you don't get it, I know you get it. So now let's continue. So hosting, you can use the public IP to host a public website. You understand? Amazon, for example, or let's say Jumia. You understand? Yeah, you can have access to it because the IP address that's used is a public IP address. So let's continue looking at the private IP. So for internal communication between instances, for the elastic IP, maintaining a consistent public address during instance changes. You see, still saying the same thing. So looking at the static lights, generally dynamic changes on instance stop and start. So it means when you stop the instance, it changes. You understand? And when you start it, you're getting another different public IP address. So the private IP is static within the VPC remains until the instance is terminated. Take note, the only one that is static is your elastic IP address. Your elastic IP address. Your elastic IP address. And there are so many ways, just that you have 5 elastic IP address that is attached to every account. So, but we are not really going to go deep into that. It's just something you should know that we have 5 elastic IP address that is as accessible for each account. So you're assigned 5 elastic IP address. So if you want more, if you want more, excuse me. So let's don't bring chosen here. So let's don't bring chosen here. Let's focus, please. Let's focus, please. I'm a chosen generation. So let's focus, please. So so AWS use case. So directly accessible EC2 instance. So it's directly accessible. You understand? So communication between EC2 instance in a VPC because it's a private IP, so you can be able to communicate. The instances can communicate between each other in a private in a VPC in a private network. So the other one is persistent public IP for a web server. I believe we already understand this. So if there's something you're not getting, can you let me know? If you like me to fly, say fly. If you like me to say fly, can you say fly? Can I get a fly? One, two. See, we have 200 and okay, no, it's not. No, I want to say 200K. Okay, we have 56 people watching. So I believe okay. Fly. So let's move. Now let's talk about NAT Gateway. So we spoke about Internet Gateway. Take notes. Internet Gateway, NAT Gateway, Internet Gateway, NAT Gateway, Internet Gateway, NAT Gateway. They serve different purposes. Quick look and tell me what is the purpose of Internet Gateway again. An Internet Gateway. Anybody? There's Chin Chin available. Who wants to chop Chin Chin? Who can tell me the purpose of an Internet Gateway? Just tell me. Just say what is the main purpose of an Internet Gateway? Who can remind me? Mm, okay. Hmm. And for security, plays the roles of security, but oh, yes, I want to get more answers. I'd like to get more response. Majority of us were around yesterday. Hmm? So it's good to be able to, so you won't get it confused between the NAT gateway and internet gateway. Good, I like that. Access to the internet. So just think of it like a bridge between the VPC and the outside world. So, okay. So let's move now. So, but before we discuss about NAT Gateway now, I want us to understand. Sorry, I meant on Monday. Sorry, there was no class yesterday. So I wanted to understand um, a resource before NAT Gateway because there's NAT Gateway is the elder brother of somebody. So you understand. So, for example, we know before there was the cloud, there was on-premise. So before there's NAT Gateway, there's actually a resource. You see, I'm not saying service. I believe we understand the meaning between resource and service now. There's actually a resource that was being used before NAT Gateway. So NAT Gateway is like the new version. And let's see that it's called a NAT instance. A NAT instance. So I want to discuss about, I want us to understand NAT instance, although it is outdated, but it will come out in the exam. You understand? It will come out in the exam. So what you just need to know is what it is. You understand? And just what it can do. So that's why I had to add it to today's class. So it's good for us to understand. So what is a NAT instance? So network access address translation instance is an EC2 instance, take note, configured to enable instance in a private subnet to connect to the internet while preventing incoming traffic from the internet. Now, I know that's like a mouthful, but the purpose of NAT Gateway and NAT Instant is one thing. Have you ever wondered? We have the private subnet and we have the public subnet. The public subnet can have access to the internet, you understand, via the with the use of route tables connected to the internet gateway. But then, what about the instances in the private subnet? How do we give them access over the internet? How do we give them access to the internet? So this where we come with NAT instance and NAT gateway. You understand? But AWS will advise you, if you go to their documentation, they advise you to use NAT gateway as NAT instance has less flexibility. You understand? It has less future compared to NAT gateway. And we're going to see the some of the features of NAT gateway compared to NAT instance. So if you have some cases that comes up in the question in the exam, for suppose that's going to be during the exam, if you watch it very well, you see in most cases you have to pick the NAT gateway over the NAT instance. I believe I've explained all we need to know. So now let's see. Imagine you have a web application, and remember, you have to configure an EC2 instance, and there are some specific EC2 instance that is used for EC2 for this NAT instance. Now it's not all EC2 instance, so there are some specific. You actually configure, and I don't want to go through the process. You actually configure an EC2 instance to serve as a NAT instance. Okay. Now imagine you have a web application running on several EC2 instances in a private subnet. So they need to download updates. So these are the reasons you need to download updates or access APIs on the internet. You can launch a NAT instance in a public subnet, allowing the private instances to reach the internet through it. You understand? If you want me to come again, let me even come again. So I told you the main purpose of NAT instance and NAT gateway, you understand, is to allow the instances or resources in a private subnet to have access, because things that you can put in your private subnet are your database. You understand, your database. You don't want it to have access. You don't want people to have access to it. So we place them in private subnets. Now, who can tell me how can we differentiate between private subnets and okay, between a private subnet and a NAT, sorry, I say private between a private subnet and a public subnet. Who can just give me something? How can we differentiate between the private subnet and the public subnet? And trust me, just feel free to throw your options whatsoever you feel is all right. So I'd like us to tell me just maybe just like one sentence, what's the difference between a public subnet, or how can you differentiate between the public subnet and the private subnet? I've even said some of the answers. Nobody should go and be checking Monday's class. Oh. It's a sin. Oh. Just say what you know. You understand? Anybody? Anybody? No, difference between how can you differentiate? I believe we spoke about public subnet and private subnet, and I've done some explanations too about them. So, in your own way, how can you differentiate between a public subnet and a private subnet? Okay. Hmm. Hmm. Okay, I'll come back. Okay, through the accessibility method, public access to internet while private no access. Hmm. You guys are trying. Some of you are too good. See, I will not hand over this teaching to some of you like this. Okay, public is for inbound and outbound. Okay, private allows. Some people are okay. Private allows. Really out. Okay. No, no, no. I can't say we are not flying. No, I dropped the question. We are not flying. Okay, okay. We've all tried. I like the fact that we all are able to contribute. So first thing, what may I do is this. How can I differentiate between public and private subject? One thing first is is the kind of resources they can house. You understand? When you think of private, something private, you understand? You don't want it to be accessible to everyone, and public, something that can be accessible to everyone. So apart from the fact that one way you can identify a public and a private subnet is by allowing the right route table to the internet gateway. But one thing you should have at the back of your mind is that the resources or the instance or the application, in this case, maybe your database server, you place them in the private subnet because you don't want it to have access to anyone. You understand? So the public subnet, yes, we've all tried. So the public subnet is think of it like where it's accessible over the internet. So you understand. So it's good to be able to differentiate between you all have tried. You all have tried. So coming back to the elastic IP, I guess someone said she does not understand. So think of the from the word elastic, static. You when you delete your instance, because when you terminate your instance rather, and you want the IP address to be static. You don't want, just because you terminate your instance, you don't want it to be that you have to assign another IP address to it. So you have to make that instance to be always be accessible via an IP address that does not change, that remains static. So even though when you terminate the EC2 instance, so you understand. So this is the use case of an elastic IP. That is why we use an elastic IP address. So it is static, unlike a public IP address that is not static. Once you terminate the EC2 instance, automatically it's being terminated because it's configured when you when you were trying to launch your EC2 instance. The person that asked that question, I believe you understand now. Hmm? So, sorry, let me go back a bit. No, that is my system pressing on the on. So let's go. Oh, no. So let's look at this analogy. So a NAT instance analogy. So think of a NAT instance as a doorman at a security building. So the private instances are like residents inside the building who needs to send requests like packages to the outside world, but they can't because they're in the private instance, because they're in the private subnet, sorry. So you understand? So the NAT instance, the doorman allows residents to send their packages out, but does not allow anyone from the outside to directly access them. This is how a NAT instance works. Its main purpose is just to give access to allow the instances in the private subnet to have access to the internet. Maybe they want to download some maybe you want to get some updates or they want to download some packages or the rest of them. So let's see now. Let's look at this architectural diagram. I believe we all can see it. So always have it at the back of your mind that your NAT instance is always placed in a public subnet. So you can see this instance, this guy here, he wants to have access to the internet. Can I fly? You want me to fly? Can I get a fly? Can I get a fly? Hope I'm not too fast. I've set like 20 questions. I said like 20 questions. So am I going to answer it all today? I said like 20 questions. And that's 5 each. Okay, so yeah. So let's look at this now. Let's look at this architecture. So the route table associated with the private from the instances in the private subnet to the NAT instance in the public subnet. The main purpose is this guy in the private subnet is tired of he wants to get things by itself, and the only way he can private subnet, and he wants to get updates, he wants to get some updates, some package from the internet, you understand, some software package and the rest of them. And because it's placed in the private subnet, the only way you can have access to the internet and get it download and to get it download for it to be updated is through this NAT instance. So NAT instance then sends the traffic to the internet gateway. Take note, it does not send it back to the instance in public subnet. You understand? To the NAT gateway, the traffic is attributed to the public IP address of the NAT instance. So you understand? So the NAT instance, what you need to know, the NAT instance must have internet access. So it must be in the public subnet. You understand? Hmm? I believe we are good. No, we are not. Levina, what's going on again? Levina, can you tell me what's your challenge so I can help you out? Levina, what's the challenge? What's your question? It's confusing, Abby. Don't worry. You see from this diagram, Abby. So I'm trying to nothing, so we are good to go. Okay. Let me take this diagram. It's confusing, no worry. So remember the purpose of a NAT instance. Remember Okay, let's start from here now. We have the private subnet, as you can see, and we have the public subnet. And the public subnets have access to the internet, but the private subnet does not. What if the server or the instance or the application in this instance wants to get updates? And someone wants to update itself, and the rest of them. It can't do that because it doesn't have access to the internet. You understand? To go and download those updates, it can't do that. So how can we give it access? So there's this guy called NAT instance, which is hold. Any difference between NAT instance and NAT gateway? Don't worry, we're going to get there. Don't worry, we're going to get there. We're going to get there. So one way to do this is by using a NAT instance. Remember, is an EC2 instance that is configured to serve as a NAT instance. You understand? So you have to do the configuration by yourself. You have to do the configuration by yourself, and you attach a public IP address to it, or an elastic IP address to this NAT instance, this guy over here. You understand? So you can give it, so you can have access to the internet. So without this internet gateway, without it having access to this internet gateway, it can't reach the internet. So now, how does this workflow go? So the routable associated with the private subnet sends the internet traffic from this EC2 instance to the NAT instance in the public subnet. So this NAT instance then sends the traffic to the internet gateway. So the traffic is attributed to the public IP of this NAT instance. You understand? One way we can identify or know a server is by their IP address. One way we can have access to a server is by their IP address. Remember, it's an address. That's why I had to discuss about it from the very beginning. If this guy does not have an IP address, there's no way this EC2 instance in private subnet is going to have access to it. You understand? So you see the power of an IP address. See the power of an IP address. Think of it like your name. So let's go on. So the NAT instance must have internet access. So in order for it to have internet access, it must be placed in the public subnet. You understand? Hmm? I believe I'm good to go. So Grace, don't let me pronounce Grace. You get it? Grace, you get it. If you get it, Grace, can you tell me to fly? Let's Grace and Adaobi. Let's get their fly. Grace and Adaobi. Let's beg them. Internet must connected to the internet gateway. We're talking about the NAT instance, yes. So sorry. Okay. Okay. I'm waiting for Grace. I'm waiting for Grace and um I'm waiting for Grace and what's her name again? Ada will be Charity. Okay, you don't understand. Can you just pinpoint what you don't understand? Is it for me to explain this architecture diagram again? So I'm still waiting for Grace and Adaobi. Hello, knock knock. Grace and Adaobi, are you there? You know that, let me go over the explanation again. Charity, what's there that you don't understand? Okay, let me go over this diagram again. So I would like us to focus, please. I would like us to focus because this is the last time I'm going to explain it. You understand? From the onset, we said the EC2 instance or the resource or the application in the private subnet can't have access to the internet. Why? Because it's placed in the private subnet. Yes, but let me just quickly run through this. So how can we give this EC2 instance? How can we give this guy in the private subnet access to the internet to do whatsoever he wants to do? So, ladies, let's focus now. Let's focus. Let's focus, please. So now the route table associated with the private subnet sends the traffic from this private subnet to the NAT instance in the public subnet. The NAT instance then sends the traffic to the internet gateway. The traffic is attributed to the public IP address of this NAT instance. So this NAT instance must be placed in the public subnet and it must have access to the internet gateway. And the way it can have access and the way it can be accessed, way it can have access to the internet gateway is to have either an elastic IP address or public IP address attached to it. Hmm? So I believe it's clear enough now. Let's move. Now, let's talk about our main guy. Now, because of this guy, we had to understand what NAT instance is. So now, this is the elder brother I've been telling you about. The one we just spoke about is the younger brother. You understand? So this is the elder brother. This NAT gateway, we said the NAT instance is, yes, Grace, we're waiting for you because you say you didn't understand. Well, let's fly. So we said the NAT instance you have to configure it is actually an instance that you have to configure. You have to set it. But now, on the other hand, because AWS doesn't want you to go through the stress of setting, launching an EC2 instance, attaching an IP address to it, attaching a public IP address to it, you understand? So they come up with something called the NAT Gateway. So it's a fully managed AWS service that performs the same function as a NAT instance, but take note, it's designed for higher availability, HA for short, scalability for it to scale, and ease of use. So it automatically handles the workload of NAT without the need for manual configuration or management. Yes, so let's don't. I don't want to go deep. I don't want to go into the associate level, so we won't be confused. So Yusuf, let's leave it like that. Yes, you are correct. So let's look at this example. If you have multiple private instances that need to access the internet, you can set up a NAT gateway, which will manage the traffic for all those instances efficiently without requiring a dedicated instance. Now, let's now let's look at this analogy. So think of a NAT gateway as a receptionist in a hotel. Think let's imagine it before I fly. Let's imagine it. See yourself in an hotel. No, now you are not the NAT gateway. Residents, private. Does that mean NAT gateway doesn't need to be associated with public IP for the private to have? You will see that now that the NAT gateway is also going to place in public subnet. But let's flow on. So Ayola, imagine seeing yourself in an hotel and there's a receptionist in front of you. You understand? Now take note, you are not the NAT gateway. I'm just saying you should imagine. So residents, that's the private instances, can send a request packages to the receptionist NAT gateway, who efficiently manage and send them out to the outside world. So the receptionist service is always accessible, like the NAT gateway, scalable, and requires no effort from the residents to maintain. So with this analogy, is there anybody that don't understand? I really pull this up, you understand, so we can really understand the concept of NAT gateway. I'm supposed to get an applause. So I believe we all understand what NAT gateway is, but there's an architectural diagram to help us even understand better. So let's fly. Now, another architectural diagram. Now you see in this case now, thank you, Deborah, thank you. And it's only Deborah, Debbie, Nabimbola. Yes. Okay. Thank you. Now let's look at this architectural diagram that explains the work of a NAT gateway. Explains the work of a NAT gateway. Thank you. I'm blushing now. Thank you. So now, if you look at this architecture diagram, and maybe one of these classes, when we are explaining which AWS service, is there any other service? Mm, I will just draw an architectural diagram, and we are going to start. Maybe it's in one of our projects. Yes, we are going to build a three-tier web application or just a two-tier web application from the scratch. You understand? To let us see how all these things work together. So you understand? We can use software like draw.io or Cloud Diary, or there are many of them out there. So because it's good for us to understand architectural diagrams, just as this. So let's move on. Thank you so much, Eva. Thank you. So as you can see now, there are two AZs. You understand what easy means? Availability zone. I won't be saying that again. You understand what easy means? So you can see there are two AZs inside the VPC within a region. Now, the route table for each subnet determines how traffic is routed. We know that by now. We know that. I'm not going back. Oh. Thank you, Rabio. Thank you. We know that now. So now in the AZA, the instances in the public subnet can reach the internet. That's the AZA. So these instances can reach the public subnet. Yes, through this internet gateway. How many of us know this guy? We know it now. Professor talked about this. Oh, sorry. Our professor talked about this guy yesterday. This IGW. So now, why the instances in the private subnets have no route to the internet? Now, that's what the AZA. In the AZB, this is the AZB. We see it. Let's zoom it. The AZB, the public subnet contains a NAT gateway. This is a NAT gateway. Oh, it's time for us to mark our attendance. Wow, I believe we are enjoying the class. We've forgotten about our attendance. I believe we should go on. Let's don't go on. No. Attendance is very important. So I believe we have to mark our attendance now. I think we have to mark our attendance now. So everybody, no, let's don't go on. No. Attendance. Let's don't continue. Attendance is very. So let's give us 5 minutes. Let's mark our attendance. Let's use that to take a short break. So once just quickly mark your attendance, it takes nothing less than 1 minute. So you can go and have your hot tea, you understand, to help you to keep you awake, maybe a coffee. No, don't let me finish it. It's 8. We know how we do it too, Debbie. So once it's 8, we have to take our attendance. Don't worry. I know I said there are 20 questions, but don't worry, we are going to find our way around it. So let's mark our attendance. And I'll see you guys. You'll see this face in the next 4 minutes. Sorry, Debbie. So this face is going out. You'll see it in the next 4 minutes. I believe. So I didn't even see the I didn't see the chat. I didn't see the chat. So I was not eating amala. I was not eating amala. So we are back. I actually the slide that I created a comparison between NAT instance and NAT gateway. I didn't include it. So before the slide is being sent to you guys, I'm going to include it. So that's what I was actually doing. I wanted to eat semo, but you understand, just take like 2 wraps before we continue. Now these countries. So let's continue. So we are back. Yes. So there are two. So let's look at this architectural diagram again. I'm not eating changes. So let's look at this architectural diagram again. So we can see in this, let's start all over again. So we can see in this architectural diagram, we have private subnets and public subnets in AZA. Yes, Semo with Egusi. See, let's don't think about this thing. Let's focus. So in this AZA, we have public subnets and we have private subnets, and within these subnets we have EC2 instances. You see these yellow guys there? They are the EC2 instances. So over here too, we have the AZB. You understand? And we have the public subnet and we have the private subnet. And in this private subnet, we have the EC2 instances, these three guys that are here. So one thing I want us to understand, and I believe I've spoken about it before, is that the NAT gateway is placed in the public subnet. So take note, it's placed in the public subnet. So let's see how let's see the flow chart of this architectural diagram. You see there are two AZs to subnet. Now, the route table for each subnet determines how traffic is routed. How many of us remember when our professor was teaching us on Monday? You understand the use of route tables. So in AZA, the instances in AZA, in the public subnet, these guys can reach the internet because they have access. They have route table that directs them to this internet gateway. You understand? So they can have access to the internet. So that the instances here in the private subnets, they have no route table. So they are just there. Yes, yes. So they are just there. You can see they have no access. These guys are just there, you understand, playing around. God knows what they are doing. I don't know. So they're definitely enjoying themselves. So let's look at the AZB now. The AZB, on the other hand, you can see the public subnet contains a NAT gateway. And the instance in private subnet, this one's now, this time around, compared to these guys, they can reach the internet, but reach the internet through this NAT gateway. You understand? In the public subnet, you can see. So you can either attach a public IP address or an elastic IP address to this NAT gateway to give it access to the internet gateway. So I believe with this few points of mine, I'm able to explain to us the flow chart of this architectural diagram. So if you don't understand now, can you speak now or forever? Just speak. Let me know. Do you understand? So if you want me to fly, tell me to fly. Understood, sir. Good. Can I get a fly? Can I get a fly? What if there are no public subnets? Will the private subnet still be able to use the internet? Now, if there are no public subnet, there are other ways, but I don't want us to dive deep into it. There are other ways, but if there is a NAT gateway, the NAT gateway has to be placed in the public subnet. Yes, so you can choose to put instance in the public subnet or not, or you cannot space your NAT gateways. Now, there are different ways to give access to your EC2 instances, and it's not for this level. So I don't want to get us confused. But one thing I want us to understand is this: if you must use a NAT gateway, a NAT gateway has to be placed in a public subnet. Now, the public subnet that you place your EC2, you place your NAT gateway, it does not necessarily have to be your EC2 instance doesn't necessarily have to be in that public subnet. It can just be your NAT gateway. As you can see in this easy A, these guys can already have access to the EC2 instance, to the NAT gate, to the internet via this internet gateway. But this EC2 instances here can't. So in order to allow this one's case not to be like this one's, we created a NAT gateway here. So with this NAT gateway, they can have access to the internet. Do you get it? You get it now. Now, let's fly. Let's fly. Now, let's talk about VPC peering. So we spoke about VPCs. Everybody understand what a VPC is? We know what a VPC is. So before we fly, who can tell me the full meaning of a VPC? Who can tell me the full meaning of VPC? Full meaning of VPC? Anybody? 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 Full meaning of VPC? So public server doesn't need NAT gateway. No, you're changing things. Oh, public subnets don't need NAT gateway. Is NAT gateway needs public subnets? Patience. Okay, okay, okay. You are just too good. You are just too good. Maybe sometimes I'll just hand over the floor to you people, to come and do justice to this. Yes. So now, but I just want to let us know this, that VPCs can communicate with each other. Yes, VPCs can communicate with each other. There's something called VPC peering. Before we dive deep into it, it allows for VPCs to be able to talk to each other, or it allows the EC2 instances in these VPCs to be able to communicate with each other. And we are going to see them now. So VPC peering for cross-region connectivity. Now, let's move on. Now, let's first of all understand what VP is again. What's going on here? What is VPC? Sorry about this. I think this just happened by itself. This was not my doing. Oh, bossy, I can't go back again because time is not on our side. So just go back to the video after this class so you can have a proper knowledge of what the diagram is. So a virtual private cloud, we all know, is a network dedicated to your AWS account. It's dedicated to your AWS account. It is logically isolated from other virtual network in the AWS cloud. That's why it's called private. That's why it's called a virtual private. So you can launch AWS resources such as EC2 instances in your VPC. Now, VPC peering connection is a networking connection between two VPCs that enables you to route traffic between them using IPv4 or IPv6. We all know what that is. So they communicate to each other using IPVs, using IPs. Now, instances in either VPC can communicate with each other as if they were in the same network. You understand? So you can create a VPC peering connection between your own VPCs or with a VPC in another AWS account. And we're going to see an example. So the VPCs can be in different regions. So if they are in different regions, also this is also known as inter-region VPC peering connection. And it's a mouthful, but there's no abbreviation for this. So the abbreviation I saw, it does not really make sense. So we have to just call it by the name. Inter-region VPC peering connection. Now let's fly. Now, let's first of all discuss about VPC peering. So imagine you have two VPCs, like we said. VPC A hosts your application servers, and VPC B hosts your database servers in the same AWS account. How can these VPCs speak to each other? You understand? Let's say VPC A, subnet in VPC A want to speak to the subnet in VPC B, but there's no way. So with the use of VPC peering connections, these VPCs, or rather these instances, can communicate with each other. You understand? Without the need for an intermediary gateway or a public IP addresses. So it's very easy with VPC peering. So you see the use of VPC peering, it allows two VPC to communicate to each other. Now let's see an analogy. No, no. Oh, I didn't put it here. I'm so maybe something has happened, but let me just quickly explain, and I will add all those things. I'm so sorry, but the analogy I wanted to give here is just imagine you created an AWS account now, and you created two VPCs. You understand? And you're using VPC A for some, let's say, for your applications where you have most of your applications that are there, like what can I say? Maybe like your e-commerce applications, and the rest of them. I create another VPC where your database services, you all know. So in order to make them communicate with each other, you set up a VPC peering connection. So the instances in your public subnet in your VPC A can talk with the instances, your database in VPC B. You understand? They can communicate with each other. So one thing you should just know that the use case for VPC peering is to allow two VPCs to discuss with each other. Now, let's look at the other one. Establishing VPC peering for cross-region connectivity. Now, cross-region is, for example, you can see in the US, you have US East in one region and US West is another region. So even with this VPC peering, and you have different VPCs in like two other regions, they can still communicate together with VPC peering. So it can also establish it can also be established between VPCs in different AWS regions, allowing for cross-region connectivity. So you understand, I believe is very, very simple. This one's are in different regions. The other one was in an AWS account, but this one are in different region, in separate AWS accounts. So now let's look at this architectural diagram, and I believe. So looking at this architectural diagram, you can see the region US is Ohio and region US Oregon. You can see the VPC. One thing I want us to just see is the VPC peer connection. You can see they can communicate with each other despite the fact they are in two different regions. So by setting up VPC peering between these two VPCs, resources in VPC A can access resources in VPC B, enabling the application to leverage resources across themselves differently. Sorry, something went on with the slides, but I hope we get it now. If you don't understand, kindly tell me to start all over again. But I purposely draw this architecture, did this architectural diagram so we can understand, and it's very simple. There's VPC peering and there's VPC peering for cross-region connectivity, where you have separate AWS accounts in different regions. So if you would like me to fly, can I get a fly? Come again, sir. I'm coming. Come again. Yes. Wow. No wahala. Let me go back. Share is FL6 again. Now, now, VPC peering. We have two VPCs because someone like organizations or big organizations they can't use one VPC. You understand, because of their resources. And so these VPCs that they've created, VPC A and VPC B, they need to speak to each other, or rather, the resources in the VPC need to speak to each other. Now, let's quickly go to the architecture diagram. How can these VPCs speak to each other? How can they connect to each other? How can they exchange, exchange numbers? How can they communicate to each other, know how this guy is doing, how VPC, what if these instances, just think these instances are alive. So how can these instances in the public subnet say hi to this instances, the instances in VPC A, how can they say hi to these instances in VPC B just to know how they are doing, they understand how was their day, but they can't because there's nothing connecting them together. So with the help of VPC peering, they can speak to each other. They can know how they are doing. You understand? So they can just say, okay, VPCB can say, the instance in VPCB can say, okay, I have some change in when I went to market today, and I would like to share it with you. You understand? Would you like to have a taste? You say, sure. VPCA will say, sure. So because of the VPC peering, they can have access to each other. The instances can quickly share the chain, and the VPCA, the instance of VPCA can say, okay, I'm going to do Amala this evening. You understand? Would you like to have a taste? And the rest of them, you understand? They can, they can, they can share. Um, they can share and speak to each other. You understand? So they can either use the chin for dessert after they've eaten amala. I believe we all get it. So just have it at the back of your mind that VPC peering allows connection, you understand, between the two servers. Hmm? You get it now? Now this one is within a region in an AWS account. What if they are in separate regions now? There's something called VPC peering for cross-region connectivity. Now, just because they are in different regions does not mean they can't still have access to each other. No. So with the help of VPC, they can still have access to each other. As you can see here, see the same VPC that was in that. Yes, there's a service for that, and we're going to discuss about it. Yes, is it not Transit Gateway? Is my professor here? Yes, it's Transit Gateway. So with Transit Gateway, more than 3 or 4 VPCs can speak to each other. But don't worry, that's for another day. So yes, more than 2 VPCs. But I don't think it's not in the cloud practitioner level. I don't think it's not there. So while I was doing my search, these are the ones. And if it's there, don't worry, we're going to pull it up for you people to understand. So you can see cross-region connectivity. You see, these ones now are in different regions. You understand? They are in different regions. They are in different regions, both in US. You understand? Like Ibadan and Lagos. You get it now. Like Abuja and Akure. We get it. So with the help of VPC peering, they can still communicate with each other. They can still share things. There's no barrier whatsoever. So let's fly. So I've explained already. Now, questions. I believe there shouldn't be any questions now. But feel free if you have questions, that's why I'm here. That's why there's this slide available for us to ask questions. So ask questions. Let's even do something. Whoever that ask question, that have a question. Can you throw your questions and let's see. So those of us that understand, can we respond to them? Let me see. Because I see professors, I see great IT consultants and the rest. You understand? They are imagined from from this gathering. So even they will even do better than me. So if you have a question, drop it in the chat, and you'll be amazed to see some people rise up and answer this question. Yeah, throw your questions. Anybody, don't be shy now. Come on, throw your questions. Nobody. So everybody's a professor now. Okay. Okay. So wait, I got a question. Let me see. So can the private IP be effective even when they are not within the same location? I don't know if you got them. I didn't get it all. Okay, I'm coming. I don't understand this. So the private IP that is attached to the instance or a private subnet, if they are not within the same location, I don't understand that question. In different regions, yes, in different countries, cross-region connectivity pairing is applicable to instances in different regions. Okay, okay. So, sir, please, can you recap on VPC pairing? So, VPC pairing, the way the instances can have connection to each other is through the IP address. You understand? It's through the IP address. So, the main function of VPC pairing, they have been a long time, you understand, since before the beginning of men. I'll come and answer this question. So since before the beginning of man, there have been VPCs, but these VPCs have been standing on their own. They don't know what's going on in the other VPC. They just know there are other VPCs. You understand, like other brothers and sisters, and they can't communicate with each other. The instances can't in VPC A, for example, can't communicate with instance in VPC B. Maybe to let's say to have access to a database that's in VPC B, you understand, to communicate the application server that is in the VPC A. So these things can happen. So someone just sat down one day and decided to come up with a way these VPCs can speak with each other. You understand? They can actually have access to the resources that is within their own VPC. So they came up with something called the VPC pairing. So the VPC pairing, with the help of VPC pairing, these guys can communicate with each other. So if there is a resource in VPC B, you understand, database servers. Okay, if there's a resource in the database server, the application servers in VPC A can have access to the database server, to resources in database server in VPC B. So let me now look at this. A question that has been sent to me. I think the person means the private IP that exists within the company. Okay, can private IP be effective even when they are not within the same location in the same company? No, they can't. They can't. So in the same VPC or within the same VPC, no, they can't. So let's move. So now we have somebody. If you are ready for these questions, while I was setting them, I had to come up with with some technical ones, the way I constructed them. You understand? Some of us, you have to sit back and really prepare for this because it's going to hit you. So are we ready? If you're ready, can I get a fly? Can I get a fly? Can I get a fly? And The people that we get is the first. How many are we here? Because some persons they want to quickly. I'm not saying they are anybody. I'm not saying they are anybody. Some persons want to quickly, just quickly fly back to see what's going on. You understand? Go back to the lectures. And also, because you guys are on YouTube. I'm not saying there's nobody here. Some people I didn't mention it. So how many are we now? We're about 60. Wow. So let's go. So I'm looking at the first 7 people to answer. You get a chin. So let's go. Now, question 1. What is the primary purpose of VPC peering? To allow instance in different VPCs to communicate directly, to connect to an EC2 instance to the internet, to create backup of a VPC, to increase the storage capacity of VPC. What is the primary purpose of VPC peering? There's nothing like one here. Okay. A. 1, 2, 3, 4, 5, 6, 7. So the correct answer is drum roll, please. It's like a simple Abby. Don't worry. You see the next 19 questions. Everybody's saying A. So the correct answer is A, to allow instances in different VPCs to communicate directly with each other. Can you give yourself a pat on the back? Yes, you guys tried. It was a mistake, sir. I wanted to write A. That's good. Well, you guys are good. You guys are good. You guys are good. Now, the next question. Next question. What is the key benefit of cross-region VPC peering? It reduces latency between VPCs. It allows VPCs in different regions to communicate. It provides authentic scaling of instances. It increases the number of available IP addresses. Now, this one is hot. What is the key benefit of cross-region VPC peering? Are we sure it's B? Zoom the question well. Zoom it well. Zoom it well. Don't say because first one is A. You now assume that you understand A, B. No. Are you sure? Don't say because my friend answered B. It's your answering B. Okay, let's see. And the answer is A. You guys are good. So it allows VPC in different regions to communicate with each other. You guys are good. You ladies are good. You're good. You're good. So let's move to the next question. What does VPC? Oh my Jesus! I can't believe I thought I removed this question. So what does VPC stand for? Ah, we say A. We say B. I'm sure it's a slip off. So everybody's answering quickly. See, I tried to tell me the questions I set that was sweating. It's not hard. Okay. So A, no wahala. So the correct answer is A. The correct answer is A. Yeah, you guys are good. You're good. You're good. Let's see. No, now. No, now. Bibian is A. Don't get it twisted. This one is public. It's a private. Now the next question. Oh, my questions choose you. Okay. Now let's see the next question. Now, what is the primary function of a NAT instance? Again. Now let's wait till some people are already typing A. The primary function of a NAT instance. The primary function of a NAT instance to allow inbound internet traffic, to enable outbound internet traffic for private instances, to manage security groups, to allocate IP addresses. Now, take your time. Which of these is the correct answer? B. A. Okay. I got one A, one B, one C. I got one A and one C. I got one D. Let me read the question again. What is the primary purpose or primary function of a NAT instance? Now we are in Who Wants to Be a Billionaire? And I'm speaking like, what's his name again? Is it Frank, Edward, or what's his name? A, to allow inbound internet traffic. B, to enable outbound traffic, outbound internet traffic for private instances. C, to manage security groups. And D, to allocate IP addresses. Yes, Frank Edoho. Are we ready now? So the correct answer is B. Congratulations, you've got yourself a B. So to enable outbound internet traffic for private instances. Now let's move to the next question. I don't want us to get to night today. So now, how does a NAT gateway differ from a NAT instance? Yes. Now this question is for the great minds, those that are actually, you understand, the pro Texas. I believe everybody here is a pro Texas. So a NAT gateway is manually managed, while a NAT instance is fully managed. A NAT gateway is fully managed, while a NAT instance requires a manual management. A NAT gateway cannot handle traffic, while a NAT instance can. A NAT gateway is only for public subnets. So B, okay. You didn't even let me finish my question. You already answered. Eh? Does that mean my questions are too simple? B. Eh. Maybe I've mistakenly gone to go and check my. Okay, let's see. So B is the right answer. Remember, NAT Gateway. You ladies are good. You ladies are good. Can you give yourself a round of applause? Can you give yourself a pat on the back? So let's see the other question now. What is the characteristic of a private IP address? The characteristic of a private IP address. It is a routable on the internet. It is unique across all networks. It is used for internal communication within a VPC. It cannot be assigned to instances. I know this one will shake some people. But I've been saying C. Don't go and say because somebody is answering C. Excuse me. C. I've only seen one A. Okay. So, and the answer is C. Oh, you ladies, you are too much. So let's quickly move. Let's move. We still have about 10 questions. So, which statement best describes a public IP address? Hope I'm not too fast, though. I guess I'm too fast. So sorry. But do you know you have 1 minute? Is it 1 minute to answer each question? Is it 1 minute or 2 minutes or thereabouts in the real examination? I think it's about 1 minute or thereabouts, if I remember. Or 1 point something, 1 minute and some seconds. If you never allow me to speak French, you've already answered. So which statement best describes a public IP address? It's only used for private network communication. This can be accessed from the internet. It is a static address that never changes. It is only assigned to NAT instances. So send in your question, send in your answers. Is it a A? Is it a B? Is it a C? Is it a D? Okay, B, 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 B. It's a B. No wahala. The answer is B. I believe that's very simple. Now, now let's stop. Let's stop. The answer is B. The answer is B. Are we ready now? If you want me to fly, can I get a fly? Or if you want any explanation, let me see so far. Let me see so far. If you want any explanation, I believe I'm too fast. Some of us have put water on fire. So you understand what I'm saying? I put water on fire for, I guess the water is boiling. Gone. So let me fly. An elastic IP address in AWS, a dynamic IP address that changes frequently, a static public IP address that can be associated with an instance, an IP address that is used only for that instance, a private IP address that can be used across multiple VPCs. You have a question. Okay. Levina, after the um drop your question, Levina, and um we are going to get a question. So B B B B B. You guys are saying B B B B. Are you sure it's B? Are you sure it's B? So B B. Okay, let's see the answer. So the answer is B. So guys and ladies, that is all. Sorry, it's not 20 questions. I'll just it's just 8 questions. It's just 8 questions. It's just 8 questions. Now the answer is B, not D. You guys are great. Can it be possible to use NAT instance to a public IP, or it's just only private IP? That question is somehow. A NAT instance has to be in a public subnet, and a public IP has to be attached to a NAT instance, or an elastic IP has to be attached to a NAT instance. Levina, I believe that's the how many again? Is it not 60? Is it 65? Yes. There's 65 questions. See, let me tell you what I'm actually doing for you guys and myself and my other colleague. The questions we are throwing out, and even after everything, we're still going to come up with like 40 questions that are set by AWS. You understand? And with these questions, trust me, even with these ones, you guys are good to go. You just eating chin chin, just eating this rush. Trust me. So I'm so happy. No, thank you. Good night. Good night. But wait, I've not finished speaking. Oh, no, I have wait. Thank you. I appreciate it. Thank you so much. So I want you guys to do us a favor. Do your research on these things. So you understand. Go do your deep research, as a cloud engineer. Do your deep research. If you find anything that is kind of a trouble, or you're having an impediment or anything, just feel free. Drop it in the in our telegram, and we are going to answer you. Do you understand? Okay, so now good night, everyone. Good night, Onoha. Good night, Miracle. So you guys should make sure one important thing I forgot to tell you. Make sure you close your eyes before you sleep. That one is very important. It's very important. Make sure you close your eyes before you sleep. I've answered your question, Levina, where you said an IP address. You don't attach a private IP address to a NAT instance. You attach a public IP address or an elastic IP address to a NAT instance. I believe you understand, Levina, now. So you guys should close your eyes before you sleep. It's very important. So, sir, you are not answering. I've answered it. Levina, your question was, can you attach, should you attach a private IP address to a NAT instance? Yes. And I said, no, you have to attach a public IP address or an elastic IP address to a NAT instance. Hey, Levina, is your question I'm still answering? Is your question? Your question was, should you attach your question? Yes, now. That's what I'm trying to answer. Should you attach a private IP address to a NAT instance? And I said no. You attach either an elastic IP address to a NAT instance or you attach a public IP address to a NAT instance. You don't attach a private IP address to a NAT instance. Why? Because it won't have access to the internet. You understand? For instances to have access to the internet, you have to attach a public IP address to them and use a route table that connects them to the internet gateway. Huh? Yes, Levina needs chin chin. You need some chin chin, Levina. Receive chin chin. Levina, do you get it now? Hey, Levina, you're saying A again. Hey, what's going on? What's going on? Is it network? What's going on? It's not Levina. It's the network. Levina, you don't mind the network. It's your network. It's your network. It's your network. So we blame the network. It's Levina's network. Network is really doing Levina strong thing. Don't mind. I said it. I know it's not you. I know, Levina. We know you're not the one. It's your network. Don't mind the network. I'm sure it must be MTN. It's a DDoS attack. It's a DDoS attack. So let's call it a day. Good night, everyone. Thanks. Good night. Good night.